Hello, my name is Karim El Mokhtari. I'm a senior researcher at the Smart Buildings Research Group at Ryerson University. Today I will be presenting an overview of the digital twin interface we're working on with our partner Fuse Forward. In our research, we are focused on creating a digital twin to reflect the state of the different assets inside each building at Ryerson University's campus. And by asset, we mean any equipment that is connected to the building automation system and that is part of the heating and cooling processes. We are working on data acquired from Daphne Cockwell complex, which is a new building where almost all equipment are monitored through the building automation system, or BAS. This is an overview of how the digital twin operates. Data from all assets in DCC are captured in the building automation system. A copy of the relevant data is stored in a NoSQL database in Fuse Forward Cloud. Each record is a timestamped measurement that is captured whenever any change occurs. NoSQL databases such as Cassandra or Elasticsearch have many advantages. They can store huge quantities of data from different buildings. They are scalable and fault tolerant. We also use a small database that holds the ontology data model. This model describes all the relationships between measurement points, assets, and locations, and can reply to queries like, give me all temperature measurement points in the first floor of DCC, for example. A web server offers an interface to end users through which they can define what kind of data they want to visualize and in which way they are aggregated. The final component of the digital twin is Autodesk Forge Viewer. That is a wonderful tool that displays a 3D view of the building on which data can be overlaid. The 3D objects are stored in the Autodesk Cloud, and data is queried on demand from NoSQL and MySQL databases. Now let's see what this looks like for a common end user. Navigation starts by the Campus Explorer, where we can pick one of the different buildings available. Once a building is selected in the Explorer, the full 3D view is loaded in the Forge Viewer. This viewer offers many basic operations. We can zoom in and out, explore different views, top, right, and back, and then to the home view again. But it becomes way more interesting when we associate the 3D view with real data coming from the databases in the Fuse Forward Cloud. How can we do that? Let's look at a few examples. Let's say I want to see all assets at level 1. In the upper toolbar, I select level 1, then I click on this button to highlight the assets. The viewer now filters only level 1 and highlights all assets in blue. In this filtered view, I can pick any one of the assets and show its properties. This is an exhaustive list of all data on this device. This includes the level, the list of all measurements and command points available in this asset, along with the mechanical and electrical properties and even the supplier website. This list can be customized as needed. Say now we want to compare temperature recordings from the last 2 weeks of January inside the room and outside in the corridor. We select these 4 assets, choose the start and end dates, the type of measurement, T for temperature, and we show the chart. The assets are highlighted with the same colors as in the charts. The box plots show that the median temperature inside is lower by almost 1.5 degrees C from the outside. But the variance in the corridor is higher as the box plots are taller. The line chart gives more details over time, and we can see a significant fall that happened on January 20th around 10 a.m. A cool feature in the viewer is that we can land on level 1 and walk inside the building. We can even change the focal length of the camera to capture more objects on the viewer. can make the view more realistic by showing all objects. How about flying outside the building and getting some virtual fresh air? Unfortunately, the streets are empty and it's better to get back to level 1. Suppose I'm a technician in this corridor looking for an asset. On my tablet, I just type the code here, FCU16, and it is highlighted for me. Let's go back to the 3D view and explore another view that is room-centered. And this is a wonderful tool to compare what's happening in level 1 globally. And let's say we are interested in comparing CO2 levels during the month of March when COVID-19 lockdown took place. Let's start at March 10. We switch to room view here. That's quite interesting. The recorded CO2 levels before March 14 were higher, and right after that they dropped to a constant minimum as no one was using the rooms after this date. If we zoom in, we observe a quite interesting pattern that happens daily. CO2 starting to increase at 8:30, then drops at 11 a.m., which may suggest people leaving the room, and CO2 levels increasing again from 12 p.m. to 2 p.m. and fall gradually until midnight. These patterns that are different between classrooms can be used to predict occupancy and even estimate the number of occupants with proper machine learning algorithms. The last thing I would like to show in this demo is that it is possible to use another color algorithm to enable comparing rooms visually using a heat map. As we are visualizing CO2 levels, the rooms with lower median CO2 levels are shown with a bright green color, while a darker green indicates a lower air quality due to higher CO2 levels. We can also define which type of aggregation function we want, and if you pick the max, these two rooms are in red as they went at least once beyond the predefined threshold of 800 ppm during this period of time. In conclusion, a digital twin of a building couples data with 3D visualizations and opens unlimited possibilities for monitoring and analyzing. What was shown here is only part of the work in progress. We are working on extending this interface to include fault and anomaly detection, a recommender system for solving them, as well as a dashboard reflecting the occupants' comfort level in the campus. And thank you for your attention.